Well, it's harder than it looks. Let's do one and let you follow all the steps to see how many minutes you need to spend for a question like that simple. In my differential equation, I certainly have one of those in the exam. I only give them usually 15 minutes. And this is really the solution of this system. Y double prime plus 4y equal ET, and y0 equal 1 and equal 5. You're going to learn this in next lesson. It's a spring mass system. And I use the linear system to solve it. So in this system, if I let the v equal y prime, and what you get is the y prime equal v, and the y double prime is v prime, and then the v prime equals negative 4y plus et, and that's right here. This is what I have. You have to write it into a matrix form. This is y derivative is negative v is v, v derivative is negative 4y plus et. And your initial conditions are 1 and 5. And then your y0 still equal 1, v0 equal 5. You really try to solve this system. You have a spring mass here, and the k equals 4. How do we do it? Let's do it. Start from the characteristic equation equal 0, then r squared plus 4 equals 0, and r squared equal negative 4. Of course, you're going to get an imaginary solution. So unless you understand the Euler theorem, you say, how can you imaginary? Well, we told you last time, you're going to get a trigonometry function. Well, what's next? I'm going to let the u equal this eigenvector, and then for the r equal negative 2i, I put it here, negative 2i, 1, negative 2i, a and the b equal 0. And then, of course, you can let a equal 0, b equal 0. That's the worst choice. You definitely don't want that trivial solution. The good news is these two equations are exactly the same equation. You only have one equation, by the way. Let me multiply 2i here. You know what I talk about. See, multiply 2i, negative 2i times 2i is negative 2i squared times 2, and it's 4, negative 4. It's 4. And then have the negative 2i here. See, that's exactly the same. If you multiply the 2i, then the second, this will become 4 plus 4a plus 2ib equals 0. The second one is negative 4a minus 2ib equals 0. Of course, that's the same thing. So we only need the one then. We don't need that. You just understand that we only allow you have one equation. If you had the two, there's nothing to do, 0, 0. So we pick the first one, negative 2ia plus b equals 0, b equal to ia. You have the freedom, you remember this. I can let a equal 1, then b equal to I, and then my vector is going to be 1, 2i. I will write it as 1, 0 plus I times 0, 2. That will be my a vector and the plus I, b vector. You remember your two solutions look like this. So cosine 2t of A minus sine 2t of B, that's the first one. Second one is the cosine, no, it's the sine 2t of A plus cosine 2t of B, and that's the second one. So let's look. That's cosine 2t times A minus sine 2t times B. That will give me a vector. It's a bit longer, like this. Cosine 2t negative 2 sine 2t. And this one, sine 2ta plus cosine 2tb, give me sine 2t here, 2 of cosine 2t. So what is this? That's my fundamental solution matrix. And then you can see the round skin equals cosine 2t sine 2t 2 cosine 2t. Because the Pythagorean theorem equal 2 cosine square 2t plus 2 sine 2t square, it's a 2. If that's a 2, then the inverse of this equal 1/2. I hope you still remember how to do the inverse. I swap this to cosine 2t, cosine 2t, put a negative here, and then 2 sine 2t. That will be my inverse. And then the inverse at 0, I need that too. It's going to be 2, 0, negative, no, 0, 1. Okay, the next step. What I need is got this integral. And then I need the inverse, which is 1/2 cosine 2t, 2 cosine 2t. Let me remember right. The inverse is, 2 cosine negative, positive, negative. 2 sine 2t, negative sine 2t. Okay, but I need to use the s because I use the t on here, times the et and the 1, that's the bt, and then take the integral from 0 to t and the ds. That's not too bad. It's just take the 1/2 out. 0 to t, you have 2 integral instead of 1. That's all you need to remember. And then you have the cosine 2s e to the s minus sine of the 2s, 2 sine 2s. That's 0, I think. Is that right? 0. Then that's wrong. Erase that. And the sine 2s es ds. Well, this is an integral. You finish that. You need to go do integral by parts, or you use what I add the method. And this integral is going to be this 5/4 cosine 2t et minus 2/5, there's 1/2 outside, sine 2t et, and plus 4/5, and that one is going to be 1/5 cosine 2t, 2/5 sine 2t et minus 1/5. Okay, you see, we just do 2 integral. And this one is going to be 1, negative 1, no, 1, 0, 0, 2 times 5, 1 is going to be 5, 2 in here. So your xt equals cosine 2t as 2, sine 2t, that's the fundamental solution, sine 2t negative and cosine 2t times this plus this. Okay, so you do need 15 minutes probably close. The end result is going to be this, not too bad. 24 over 5 cosine 2t and the minus 8 over 5 sine 2t plus 1/5 of et, 12 over 5 sine 2t plus 4 over 5 cosine 2t plus 1/5 et. That's your solution. How do you check? You take the derivative again, but you check the initial condition. 25 over 4 plus 1/5, that's exactly 5 if you let the t equal 0. And 4/5 plus 1/5 is exactly 1. At least you can check the initial condition. We solved it. Not too bad. We just solved the two differential equation system.